Hello, Stockton Astronomical Society. On December 21st, we have a solstice coming up, along with another event that's pretty cool. But one of the questions people ask is, why is the latest sunrise and the earliest sunset not on the solstice? I mean, if the sun is as low as it's going to get, why isn't that the day that we have our latest sunrise and earliest sunset? So I'm going to use a paintbrush here to show you what's going on with what's called the analemma. So you maybe have seen the analemma before. It's let's get a different kind of drawing here. It's the thing on your old globes that looks like that. Looks like an 8. It's fat on the bottom, skinny on the top. Pardon my lousy drawing. I haven't seen them on new globes lately, but you might have seen them on old globes where the equator's right here. Right here is the Tropic of Cancer, and down here is the Tropic of Capricorn. Here's the tropic area, here's the tropic area. That's 23.5 degrees up, 23.5 degrees down. It's the position of the sun at a particular time every day. Alrighty. Trying to click these out so I can start again. So we have three things happening. One is the tilt of the Earth is tilted 23.5 degrees from the plane at which it orbits the sun. And so as it orbits the sun, that pole doesn't precess. It takes 20-something thousand years for it to precess, but in your lifetime, it will always be pointing pretty much at Polaris. So as it goes around the sun, it keeps that tilt going. So as a result, when the northern part of the axle is pointing towards the sun, the northern hemisphere summer, at noon the sun appears quite high. Then when we're on this side and the northern pointing of the pole is pointing away from the sun, then the sun looks low at noon. So let me transition over to the other screen. So the summer, at noon, the sun looks like it's up here. Then in the equinox, it looks like it's here. And then in the winter, it looks like it's here. So as the year goes on, the sun goes high, June 21st, then it goes low. Fall, autumnal equinox, and it goes down. There's the solstice, which for us would be the winter solstice. For Australia, would be the summer solstice. Then back up and March 21st, and so you would think the sun would just look like it goes up and down and up and down and up and down, but that is not the case. I mean, it is the case, but there's more to it. So here's the deal. Here's the sun, and here is the Earth orbiting the sun, and the sun isn't really at the center of the orbit. It's at a focus because the orbit is actually elliptical in shape. So that's it exaggerated. It looks kind of more like this. Looks like a drunk drew that. So as we're coming along this way on our orbit, we're close to the sun, so we're going fast. I try to draw the word fast here with my mouse. Whoa, I almost pulled that off. When we're out here at the aphelion, this is the perihelion. We're out here at the aphelion, we're going slow. All right, I'll write an S for slow because I can't draw. Now, the Earth rotates every 23 hours, 56 minutes, and 23 hours, 56 minutes, and 4.1 seconds. How's that? Something like that. So as it's rotating, it doesn't alter its time. It does, but it's like we adjust it by a second every few years. It's really a good clock, just the fact it's constant. But since we're going fast here, then instead of seeing the sun at noon overhead, then by the time the Earth rotates around, we've gone farther. So there, we rotated around one time. We've gone farther. And out here, in that period of time it takes to rotate, we've gone slower. So as a result, the sun creeps a little bit to the right, it creeps a little bit to the right, it creeps a little bit to the right as viewed from that. Then it evens itself out and goes the other way. So then it comes back and goes the other way. Then it evens itself out and goes back the other way. So the sun has a right and left component during the year. And it's because the sun maintains the Earth maintains its rotational rate, but it alters its orbital rate. And so in a mean solar day of 24 hours, sometimes the sun looks like it's ahead and sometimes it looks like behind. So not only does the sun appear to go up, summer, down, winter. Now remember, it's not the sun moving, it's our aspect of the way we're looking at it. But it also has a right and a left thing. So we would expect it to draw a figure 8 in the process of going up and down and right and left. But it's not a perfectly symmetrical 8. It's fat on the bottom and low and small on the top. And so here's why it's fat on the bottom and small on the top. There's Earth's orbit, really exaggerated. There's the sun. That's supposed to be an ellipse. Now, we're going fast here and we're going slow here. So the sun moves to the side one way here, and then it moves to the side to get back to this thing over here. But the angle at which we're looking at it is so much bigger here that it... I can't draw this very well. I know, let's do a line. The angle out here is much smaller than the angle over here. And so when we're close to the sun, which is in the winter, the angle is, the right and left angle view is much bigger than when we're in the summer. So as a result, the sun goes up and down. It goes right and left. But in the summertime, the viewpoint of how far to the right and left it goes is smaller. And in the wintertime, the viewpoint of how far right and left it goes is bigger. And so we end up with this figure 8 looking thing. So before I go on to the earliest sunrise and, latest sunrise and earliest sunset, I'm just going to show you Google. Google's our new god. Anything we want to know, we just click Google. We're going to go NLM and images. And so here are photographs of the analemma. What these guys do, let's find one at noon time. There's one at noon. Yeah, there, okay. This is at dead noon every day. Standard time. They don't make an adjustment for daylight savings. Well, they make the adjustment for daylight savings time so that the camera is shot at the same astronomical noon every day. So this is December 21st, and there's June 21st. The where they cross is not the equinoxes. The equinoxes are down in this part down here. So from here to here is almost 47 degrees, because from here to here is 23 and a half, and from here to here is 23 and a half. Okay, so that's at noon. Let's look at sunrise. So sunrise would be this one here. Now, this is Greece, so they're a little further south than us, but here's the bottom line. There is December 21st, but check it out. That would be the latest sunrise, because it's lower. Notice that December 21st being at the bottom of the bowling pin is not the lowest altitude at the moment of sunrise. And furthermore, the top of the bowling pin is not the, this is summer solstice up here. The earliest sunrise would be when the thing comes up and hits the horizon, which would be on that guy, not the top there. So as far as the December, excuse me, as far as the December sunrises go, this is looking east at sunrise. You can tell by the tilt, it's pointing north. That is the sunrise position for the sun on the solstice. Now remember, it was over here when it rose. But this guy's actually lower, so it rose later, and the latest sunrise would be whatever date the sun is at that point. Let's go to the sunset. It's got to tilt the other way. So here's the sunsets. This is the December 21st sunset, and the one that's missing, that would be right about here. Must have been cloudy the day they wanted to shoot that, but right about where the little finger is pointing, the sun is actually lower in altitude for the latitude of this photographer, and whatever date that one right there would have been the latest sunset. So the earliest sunrise, let me try that again. The latest sunrise and the earliest sunset do not occur on the solstice. They occur wherever your latitude tells you the bottom part of the bowling pin will be. We have the same effect in the summertime. It's just the other way around. So, I kind of made a really awful presentation of that, but that is a description of why the latest sunrise and earliest sunset do not occur on the winter solstice. Speaking of winter solstices, we have an extra event this year on the winter solstice. We have a very rare conjunction of Jupiter and Saturn. They're going to be 1/10 of a degree apart. The moon is a half a degree. So they are going to be 1/5 of the diameter of the moon apart. That means we'll be able to see both of them in the eyepiece at fairly high power at the same time. So you're probably never going to live to see this again because the next one is in 2080. Some of you will, I'm sure not. The last one was a cajillion years ago. But this is really cool because you'll be able to see two gas giants in the same field of view at the same time. Last time I saw this was Neptune and Jupiter in the, was that 2004? I can't remember when that was. But here we have two gas giants, and they're bright, bright giants. So that's going to be really cool. But there's going to be, if you've got a good enough scope and a good enough sight, 7 moons of Saturn and 4 moons of Jupiter, you should be able to see 11 moons at the same time. Now, I think it's Ganymede is in front of Jupiter, so that one might be tough. So we might be seeing 10. But it'll be there, so technically you're looking at it, you just don't know it, so there's 11. So that's 13 solar system objects in the eyepiece at the same time. You're never going to see that again. I don't care how old you get, you're never going to see that again. Why is this happening? So, Jupiter and Saturn have a synodic period of 19.6 years. And so what happens is Jupiter goes around every 12 years. Saturn goes every 29 years. It's 11.88 and 29.7. So, if you look at the degrees per day that they're moving, and see that Jupiter is going faster than Saturn by some fraction of a degree, you divide that from 360, and you can count how many days it takes for Jupiter and Saturn to lap each other again. And if you convert that to years, it's 19.6. So let's just call it 20 years. Every 20 years, Jupiter and Saturn go through a conjunction. So we ought to be able to see them in the eyepiece at the same time. Well, their orbits are tilted with each other. So Saturn might go up and down like that. Jupiter might go over like that. So when they line up, they may not be at that crossing point, and they might be 5 degrees apart. So if you get a conjunction that's close to their crossing point, the closer they're at that crossing point, the closer they are to each other. I've never researched to see if they are ever physically occulting each other. Somewhere along the way they gotta. Maybe I'll try to figure that out sometime. That would be, I don't know, hundreds of years separate. I don't know. It'd be good research. So anyway, this time around, they're 1/10 of a degree apart. That's close. You're not going to see this again. If you miss this and it's clear. Anyway, it's going to be in the, for California viewers, it's going to be a 4 p.m. to 7 p.m. thing, because it'll be dark enough to see them for most people around 4 p.m. I got a way to find them in daylight, but they're going to be that way and the sun can be that way. So that's even going to be hard. So you got to wait for the sun to go down. And once it's down, you'll be able to see it for about 3 hours. I think you'll be able to find them at 4 p.m. and they'll be on the horizon at 7 p.m. And that'll be it. So you need a really clear sky and you need a very low western southwest horizon. I'm going to head to Highway 4 because that'll get us up over that December foggy junk that the valley has, and we'll have a nice low horizon. Should be able to catch them. Another place would be that cleared area at Peddler Hill, but it's December and there might be 6 feet of snow. You don't want to go to the heliport. Trees. Well, take a chainsaw. So I'm thinking of Highway 4. And really, you don't want to miss this. There are a few things that you're never going to see again. You might not be that interested in now, but you might be later on. And so you might as well nail it. All right, so I covered 2 things. One is, why is the latest sunrise and earliest sunset not on the solstice, the winter solstice? And the other one was, do not miss the Jupiter-Saturn conjunction that's coming up on the same day. Clear skies, everybody. I hope this was of some use and of some entertainment for you. It was a nightmare for me. I don't do this very well. Bye-bye.